Hello students. Today we're going to do Saxon Algebra 2, Lesson 2. We're in the review section of Algebra 2. In this lesson we will review negative exponents, the product and power rules for exponents, and circle relationships. Remember that a product is the answer to a multiplication problem and a power is another name for an exponent. Also, don't forget that x to the 0 power equals 1, or anything algebraic raised to the 0 power equals 1. Number 1, negative exponents. Remember that a negative exponent is a form of notation. The definition is x to the minus n equals 1 divided by x to the n. But you deal with negative exponents just like you deal with positive ones. Here's the product rule. X to the n times x to the m, I have a multiplication problem there, equals x to the n plus m. So if we had y times y to the minus 3 times x to the 4 times y to the 5 times x to the minus 10, we do the same thing. We would have y raised to the 1 plus minus 3 plus 5 and x raised to the power of 4 plus minus 10, which gives us y to the third, x to the minus 6. Similarly with the power rule, where you have x to the n, quantity raised to the m, equals x to the n times m. So we have x squared, y to the fourth, z to the fifth, k to the minus 2, all raised to the third power, which is going to be distributed x to the 2 times 3, y to the 4 times 3, z to the 5 times 3, k to the minus 2 times 3, I'm still in the way, which gives us x to the 6th, y to the 12th, z to the 15th, and k to the minus 6th. Making negative exponents positive. By the definition, the reciprocal of x to the minus n is 1 divided by x to the n. In the same way, the reciprocal of 1 divided by x to the minus n equals x to the n. Thinking in terms of fractions, the sign of an exponent changes when you move it from the numerator to the denominator. So if you have x to the minus n, that's like a fraction, x to the minus n divided by 1, and when you move it to the denominator, it becomes positive. 1 divided by x to the n. This also happens when you move a variable with an exponent from the denominator to the numerator. So 1 divided by x to the minus n is clearly in the denominator, and then you move it up to the numerator, x to the n divided by 1, and then you can get rid of the 1, and it's simply x to the n. Some of the finer points of negative exponents. Number 1, 3 raised to the negative 3 power. This one is easy, just follow the definition. 3 to the minus 3 equals 1 divided by 3 to the positive 3, which is 1 divided by 27. 2, 1 divided by 3 to the minus 2. This one is not too bad. We just move it to the numerator and it will become positive. So you have 1 divided by 3 to the minus 2 becomes 3 squared, which is 9. Number 3, minus 3 to the minus 2 versus minus 3 in parentheses to the minus 2. These two can be endlessly confusing for algebra students. The parentheses are the key. So let's deal with that first. You have minus 3 in parentheses raised to the minus 2 power. The parentheses contain the minus sign and the 3, so they go together down to the denominator like that. 1 divided by minus 3 in parentheses, and now the power is positive squared. which is just going to be 1/9. But minus 3 to the minus 2 has no parentheses. What can we do? When there are no parentheses, you could use PEMDAS. Parentheses, exponents, multiplications and divisions, additions and subtractions. No parentheses, exponent, no multiplications and divisions, a kind of sort of subtraction. What's kind of sort of? It's short for kind of sort of or similar to, as in sashimi is kind of sort of like sushi. The minus sign is kind of sort of like a subtraction, if that helps you remember it. So using PEMDAS, you would do the power first and then the subtraction. Exactly like this, as if there were parentheses around the power and the minus sign was outside the parentheses. So here we go. Minus 3 to the minus 2. We're going to make that minus sign red, so we're going to save it. It doesn't go down to the denominator with 3 to the minus 2. When 3 to the minus 2 goes down into the denominator, it becomes 3 squared. And so the final answer is minus 1/9. Lastly, here's one that has everything. Minus 3 in parentheses to the minus 3. This is actually just a variation of minus 3 to the minus 2, which we just did. Parentheses keep the things inside together. We do the power first and then the subtraction. So we've got minus 3 to the minus 3, which is minus 1 divided by, we lost the power there, minus 3 cubed, which equals minus 1 divided by minus 27. And look what happened in the denominator. We got a minus 27 because minus 3 to any odd power is negative. And so the final answer is 1/27. On to the product theorem for exponents. We know that a product is the answer to a multiplication, and we already looked at this briefly. The main twist for Algebra 2 is long strings of several variables to untangle. Like that. Y times y to the minus 3 times x to the 4 times y to the 5 times x to the minus 10, which we already untangled. And we got y cubed x to the minus 6th. If you have long strings in both the numerator and the denominator of a fraction, it's probably best to do the numerator and denominator separately, and then bring everything up to the numerator, unless the problem tells you to put everything in the denominator. On to the power theorem for exponents. We also already briefly looked at this. The main twist in Algebra 2 is that the power outside the parentheses rules all the powers inside the parentheses, whether they are in the numerator or the denominator. For example, x squared, y to the 4th, z to the 5th, k to the minus 2, raised to the 3rd power. We already did it. There's the 3rd power being distributed through everything, and we end up with x to the 6th, y to the 12th, z to the 15th, and k to the minus 6th. Okay, here's one. We've got x squared z divided by y squared r to the 4th, the entire fraction squared. So that gives us x to the 3 times 2, z squared, divided by y to the 2 times 2, r to the 4 times 2, which is x to the 6th, z squared, y to the 4th, divided by y to the 4th, r to the 8th. On to circle relationships. Circles have radii, r, and diameters, d. The diameter is twice as long as the radius. The perimeter of a circle is called the circumference. The circumference of a circle is pi times the diameter, and the area is pi r squared. The twist in Algebra 2 is going back and forth between circumference and area. Here's example 5. The area of a circle is 12.2 square meters. What is the approximate circumference? To calculate the circumference, we need the diameter. Can we get the diameter from the area? Yes, but not directly. The area equals pi r squared. Therefore, 12.2 equals pi r squared. So let's use pi equals 3.14. Then we're going to divide both sides by pi. We're going to divide 12.2 by 3.14, which we're using for pi, and we're going to divide pi r squared by pi. And then we see that we get 3.89 equals r squared. So now, using a calculator, we take the square root of both sides, and we find out that 1.97 is our radius. So now that we have r, we can get d, which is 2 times r, or 2 times 1.97, or 3.94. And now finally, we can get the circumference, pi times the diameter, 3.14 times 3.94, which is 12.37 meters. Circumference is a linear measurement. The units are meters, not meters squared, so my picture isn't obscuring anything important. And example 6. The circumference of a circle is 10 pi centimeters. What is the area of the circle? It's nice to see pi. This problem gives us the circumference and asks for the area. We can solve this, but not directly. We need the radius to get the area. Here's how we will get the radius. The circumference equals pi times the diameter. And r equals 1/2 of the diameter, and we're home free. So that's what we're going to do. So let's do it. 10 pi centimeters equals pi times the diameter. We can divide both sides by pi, and we find out right away that the diameter is 10 centimeters. The radius is 5 centimeters. The area is pi r squared, 25 pi centimeters squared, and we're finished. I hope this video helped you to review these concepts and master this material. I'll see you next time.